Hey again, so what we're going to do now is actually create some tabbing at the top of our side plate so that we can start putting our top plate on. I'm not exactly going to show yet exactly what our top plate is going to look like, but at the very least you should have some idea now that in order to make the robot pieces fit kind of nice and snug together, that we want to actually make some cuts in the actual metal so that they fit nice and snugly, and the bolting is just to keep everything in place without actually flying off. Okay, so let's get to that. What I'm going to do, so remember this is what our side plate should sort of look like now. I have my slots and my gearbox associated with this. And so in order to put something on the top, I'm going to want it to slot in or to at least rest on the top without sliding back and forth. And to prevent it from sliding back and forth, it's going to have the top plate is going to have tabs, and so I'm going to need to create some form of like squared slots or just little cutouts, teeth to, or I guess anti-teeth to allow the top plate to fit into. So let's create a sketch. Once again, yet another sketch on this plate. So you can start seeing that I have lots of sketches associated with cuts and extrudes here. And now what this sketch is going to do is it's going to create a bunch of holes or teeth holes in the top of my robot. So remember what we're going to do. Let's just start off with one corner rectangle, and then kind of go from there and see how many we can fit on. So what I want to do for our rectangle, the width of my rectangle I want to make exactly 1 inch. So that's what I'm going to do here. I'm going to make this exactly 1 inch. Now the depth of it, that is always fixed. That's not up to you. That's up to the metal. And hopefully you realize by now that the metal is exactly 1/4. The thickness of the metal is exactly 1/4 inch. Now we're faced kind of with a question of where or how do we place all of these teeth along the top of this robot. Now what I don't want to do is I don't want to have a million teeth along the top, because that's going to be much longer to cut, as well as the fact that it just makes it look not nearly as nice. So let's just play around with the linear sketch pattern at this point. I'm going to click on linear sketch pattern, and I'm just going to click on this box. And in my x-axis I'm going to make let's make 6 of them. And I guess I have to click on all of these. And my spacing, I want my spacing to be every 4 inches. And the reason why I want my spacing to be every 4 inches is because it looks horrible if it's every 2 inches. I've done that before. And you can see that you get a grid that looks like this, and it's just going to be kind of a nightmare. So let's do 4 inches. You can even do 6 if you really want, but if you do 6, then your conventions are going to break from mine. And any form of top plate that you put along here is going to need to be at least 7 inches long in order to take advantage of having 2 of these slots. Because if I only put a top plate on one of these slots, then clearly a bad thing is going to happen, because it's going to tip back and forth. It will basically use the slot itself as kind of a fulcrum and want to slide up and down. So that's what we don't want to happen. So I'm going to put this back to 4 inches. And I'm just going to keep increasing the spacing, the number, until it looks pretty good. So yeah, let's say something like that. Now, what I'm going to try is I'm going to try to make actually I'm going to cancel this, so I can see that I have 9 of these slots here in the first place. So I'm going to cancel that linear pattern for a second. You'll see why. I'm going to drag the slot along the side here, and I'm going to use that trick that I've been using before, where I create a center line just as a point of reference on my slot. But what I'm also going to do is I'm also going to create a center line from the center of my robot plate. And me making a center line of my robot plate allows me to bring the slot straight into the center here. And now what I can do is, now I can use my linear sketch pattern, and I'm just going to highlight all this. I guess I can't highlight all this. I'm going to go back to 4 inches, and I'm going to go 9, I suppose. And unfortunately, it doesn't allow me to go both ways. So I'm not going to have 9. I'm obviously going to have 5 in that direction. And then I'm going to do the exact same thing. So what I can do is I can do one of two things. I can either do the same thing, the linear sketch pattern, in the opposite direction, or I can use my trick that I love doing, and is by mirror entries, by mirroring all of those entries along the side like that over there. And you can see that that has created a nice little a nice array of slots. Everything looks kind of crazy ugly right now, so I'm just going to kind of exit the sketch for a second and make sure that it does what I want it to do. I'm just going to make an extruded cut and press OK on that. And my extruded cut was incorrect, so again I need to remind that I'm doing through all, and so now I've got my little jagged teeth at the top of my robot. The next thing that I want to do is create slots associated with this, and I don't really need a lot of slots. Really, I only need one to kind of keep the whole thing down, and the rest of it should kind of flow from there. So let me create a series of slots in the exact same way. And I can even just do this in the same cut extrude, but I'll just make a new one, a new sketch. So I'm going to go to Sketch, Sketch, and let us make some more center lines because we are clever like that. I'm going to make another center line. Oops. Make another center line right here. And then again do the exact same thing that I've done before. Now these slots are a little bit different, and the reason why I say that is because they don't need to be as wide as the last ones were. They can be as long, so making it 3/4 of an inch is perfectly okay. So 3/4 of an inch. That's perfectly okay. But in terms of width, their width absolutely does not need to be the same width. And so what I'm going to do is I'm going to do it as 6.2 millimeters, because what we're going to do is we're going to use M6s on these for these slots instead, because you don't need nearly the amount of strength that you do for holding the whole robot together. Actually, I realized I made a mistake. I don't need slots at all in this case, so I'm just going to exit this sketch and delete it because I don't need it anymore. Because what we're going to end up doing is we're probably going to weld any of our tabs along the top, or any of our top plates along the top here. Okay, so let's generate the top plate associated with this. So let's get out of this part and into the actual assembly. And so now you can see that I can create a top plate that connects pieces like this here, 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 and here in various ways, shapes, and forms. And so in order to do this is by creating I guess a little piece that has a bit of an extra nub on either side that has at least 2 tabs on either side of it so that it's able to actually fit down. So let's just go ahead and create one of those. So I'm going to go and create a brand new part, I'm going to need a few references for this brand new part, but let's go to Sketch. I'm going to create it in the top plane because that's going to be very easy for me to place it once I do that. At the start, I'm just going to create a good old trusty center rectangle. And the width of this rectangle is going to be something that I measure here. So I'm going to go into my robot, and I'm just going to measure the distance from this plate to that plate, so the outside of both of these plates. And that should be exactly 2.25 inches. So I can go ahead and do that in my document here. So I'm going to go ahead and smart dimension this width of this, and that's going to be 2.25 inches. And now the length of it's going to be a little bit tricky. I want it to be able to overcome both of these tabs. So let me measure that distance, and that distance should be obvious. Hopefully you get the amount that you expect to, right? If I measure from that side there to this side there, gives me 5 inches exactly. So that's good. And for my own reference, I'm going to measure what the distance is from here to there. And that's 1.25 inches. So I can give an extra inch on either side of this. So I can make this a 7-inch piece, and it should be able to fit into this assembly. So let me go ahead and make this 7 inches long. Wow, I'm 7 inches. And now all I have to do is make a couple of cutouts and make sure that they are exactly correct. So I'm going to go ahead and create another. I'm going to exit this sketch, and I'm going to extrude it. Features, extrude, and that's going to be 1/4 inch. Done. And now I'm going to do another sketch on this, and this is where I'm going to create the insets essentially of where this is going to be going in between the two plates of the robot. So let me create some very useful lines of symmetry. There's one useful line of symmetry, and then here's going to be another useful line of symmetry. Okay, and next what I'm going to do is I could even just create a center rectangle and end up cutting out more than I actually need. Yeah, so I can smart dimension this. I make the length of this rectangle. I want to make that 3 inches. Because remember, the length between the edges of the tabs are 4 inches, so the inside of the tab length is going to be 3 inches. And the width of this, I could make it either the width of the, or I can make it the distance from the edge of here to the edge of here, and I'm just going to make it 1/4 inch because that's the amount, that's the width of my metal. And then one more time, I am going to take, I'm going to make a corner rectangle instead and do the same thing like this, where I can essentially create a center line and I just need to smart dimension this here. Oops. Smart dimension. and this needs to be 1 inch. Okay. And now, again, I use my tricks. I'm going to mirror entries. This, and mirror it about. I think I can just. Actually, if I just do mirror entries, I can just click on one of these, right? It does all of them. Nope. Okay, mirror entries. Click on the whole thing, and mirror that about this center line here. So now I have 3 pieces, and then finally I'm going to do mirror entries, and I'm going to just highlight all of this, and I'm going to mirror it about that line there. Press OK, and then I'm going to exit the sketch, and I'm going to go to Features, Extruded Cut, and again I'm going to do Through All, press OK, and so now I have the plate that should be able to fit into my assembly. One thing that I forgot to do is I forgot to give it a little bit of extra tolerance. So I can do this one of 2 ways. I can either give extra tolerance on the base, or I can give extra tolerance here. And so what I'm probably going to do is give a little bit of extra tolerance on the base. So let's go to the base for a second. I'm going to open the side plate here, and I'm going to go in and give a little bit of tolerance to this. And so instead of making it 1 inch, I'm going to make it 1.01 inches. And then I'll just press that, and everything should be completely fine. Save that, go back to my assembly, rebuild the assembly, and now I can import that component that I've created, which I haven't saved it, so that's why it's not able to import it. So let me go back and save this part, and I'm going to call it topplate. Insert components, topplate. Now you can see that here's my topplate. Now hopefully everything fits nice and snugly together. So let's try it. So I'm going to click on Mate. I'm going to click on this here. I'm going to click on that there. There's one mate. And I click on this here. And click on that there. That's my other mate. And finally, I click on the underside of the piece with the top of that. And press OK there. And I'm going to say OK to that. My mates are doing well. And one thing I can do is I can do something like interference detection. And I can just press calculate on the robot base. Normally you wouldn't just press calculate on the robot base, but because there's so few pieces, it can calculate things very quickly. You can see it says no interferences. So that means that everything here is working well. You can also see that this extra little bit of tolerance here is keeping everything looking relatively nice. So you can see that extra tolerance is happening over there as well. And now what I'm going to do is I'm going to go back, and the last little bit here is just edit this top plate so that it can have some slots in it. And so in order to do that, again, we're going to do the same thing that we've always been doing, and that's just making patterns. I'm going to go into Sketch, I'm going to click on this here, and I'm just going to click a straight slot. Actually, again, I'm going to create my little trick where I make a center line from here to there. I'm going to create another center line from here to there. And just as a check, this should be an integer number of inches. Yep, that's 2 inches. So I should be able to do exactly what I want to do. So I'm going to go back into my sketch and create a straight slot that goes from here to there. Again, it doesn't really matter, but what really matters is the center of this. I should have it lined up straight on the center of this center line. And I'm going to do what I've always been doing before. I'm going to make this 3/4 of an inch, and I'm going to make the width of it 6.2 millimeters. And I'm going to get out of Smart Dimension, and all I'm going to do is a linear sketch pattern and then near entries. So let's do a linear sketch pattern of this whole slot. I'm going to create their spacing should be 1 inch apart, and I'm going to press OK on that. And I'm going to do near entries. So I'm going to get out of that. Near entries of those slots about this line. Boom. Done. Exit the sketch. Features. Extruded cut. Through all. Now we're done. And now we've created a nice little grate. It looks like a grate up here. Top plate that will serve as basically a way of fixing things to the top of our robot if we need to fix anything. It also provides a nice little bit of security as well if we need that security. So what I'm going to do is I'm just going to go into the assembly. You can see here that I can fit multiple of these all the way along down here. I probably am not able to fit to be able to fill up all of these slots if I look at this correctly, because I have 1, 2, 3, 4, 5, 6, 7, 8, 9, and these top tabs take up a even number of them. But you don't even have to cut that many of them. Really, you can just cut like 1 or 2, and then be done with it. Okay, so that is how to create these little top tabs here. What I want you to do is basically decide how you're going to be mounting things to the bottom of your robot. I would suggest placing some of these little slots in the bottom and then creating a bottom plate that will slot through there. And you can make that out of various amounts of either polycarbonate or Delrin, or even metal if you want to use metal as well. But that's something that you should be thinking hard about on how to fix things to the bottom of your robot. I think once we start moving into groups, that's something that you're going to be able to start executing on your own. Okay, so that is the end of the tutorial for the basic parts of your robot. What's left to you now is just decide how you're going to make a nice pattern in the sides. You can make it a different pattern by using different pieces, or it can just be the same pattern across all sides and the front and the back. But please do make sure that it's reasonably good looking, as well as reasonably cutting out a lot of weight. All right, thanks a lot for watching.